So let's first address that. And then what we'll do is bounce to your second question. So when we talk about scientific notation, it kind of ties back to the sig figs that we talked about last week. So when we looked at sig figs, we could write numbers both really, really big and really, really, really small. Okay? And within those kind of systems, say if we had a really, really, really big number, I'm going to need some tracking on that, more or less. Okay? We may not want to write all those zeros because maybe those zeros are just acting as placeholders and I have no information about what the value actually is. So in that case, me writing the 0 is kind of obnoxious. So what I could go through and do is convert this into scientific notation. In scientific notation, I take my first digit between 1 and 9. Okay? So it has to be a number between 1 and 9. So in this case, 1's boring. Let's make it something else. What's a more exciting number? 8. Cool. Thank you. So we'll take 8 and we'll put a decimal point. So we put our first digit in the ones place, and now we have a decimal point. All right? Then we will list however many digits after that are significant figures. So this could be a scenario where in this number that I've written out here, 3 of those zeros are significant. In this notation, it's impossible to tell that, okay? Because I can't differentiate the 3 significant zeros away from all the other zeros. Right? When I go into scientific notation, I can differentiate that because now, because of that decimal point, I know those zeros are significant. Yeah? Okay. But I don't want to lose the meaning. Right? So in that first big expression up there, I've got 8 trillion. Let's go with that. Right? And in the number I've written down below, that's just 8. That's a big loss in meaning. So what I want to go through and do is ensure that that 8 is getting placed in the trillion place. And I'll do that by including powers of 10. So times 10 to the, and now it's going to tell me how far out I want to place that. So this power of 10 is effectively my placeholder. Okay? Or it's, yeah, my placeholder. Okay? That's going to correspond to how far out I want to move that. I did this in sets of 3, presumably, so there's 3, 6, 9, 12. Okay? I'm going to be real surprised if I actually did that math right. Okay, so I want to move the decimal place 12 spots. Okay? So I'm going to say 12. 10 to the 12 is how many places I'm moving the decimal. Be a little bit careful on that because I'm going to have to count it again because I don't trust myself right now. Okay? This original number that I'm looking at, is it really big or is it really small? It is big, so I want to make it a positive 12. That's how I would do it. You may hear a reference, well, you're moving the decimal place to the left or to the right, and then it's positive or negative. And ultimately, depending on which direction you're converting, going into scientific notation or out of scientific notation changes the direction you move the decimal point, which adds all sorts of confusion. So I would argue just how far are you moving the decimal point? Do you want the number to be big? Make it a positive power of 10. You want the number to be small? Make it a negative. Okay. Before we get to 2 questions, and I saw 2 hands, I genuinely don't trust my counting ability. That's where my decimal point started. I went 1, 2, 3, 4, 5, 10, 12. Hey, look at that. I did it right. Okay. 12 spots. Okay. So if you've ever looked at a calculator, like the graphing calculators, and you see these little curved things, that's where they're coming from. Someone's trying to count decimal places for doing a shift. Okay? You shouldn't be doing it on your calculator with like a pencil. What you should just do is tell your calculator to convert it to scientific notation, and then you don't have to think about it at all. It does it for you, just for the record. Okay? That's kind of our fundamental behind scientific notation. To sort of touch on your first point. Question?
Why did you take the first 3 zeros?
Say again?
Why did you take the 3 zeros?
Okay. Why did I decide the first 3 zeros were significant? Okay. At this point, we just decided. Okay. Why did I make that decision? Okay. The reason I wanted to make that distinction is to bring up a couple kind of points. When we look at just an individual measurement, this all looks like decimal points now. Okay. This measurement, if we lose that decimal at the very end, becomes kind of challenging. how many significant digits are in that measurement? The big, long, expanded number. And for people being like, well, it's questionable. It's not questionable, actually. It's 100% explicit. There's only one answer to that question. There's one. There's only one significant digit in that number. Okay? And that can become problematic because maybe those zeros are significant. Some of the zeros are significant. It depends on the measurement device. So writing that number out, I don't know if any of those zeros are significant or not. Okay? So what I went through and did for the sake of this assignment, as I said, or this question, is I said, you know what? These first three zeros are significant. Why could I not pick the last three? Why could I not say the three zeros that are significant are the last three zeros?
Something you used to get that number is too big.
If I say the last three zeros are significant, what does that mean about all the other zeros? They are also significant because they would be bound by two significant digits. Okay? So if I just want three zeros to be significant, it must be the zeros closest to the 8. Okay? Economic?
How do you decide if it's like 1 or 2 or 3? Is it just...
How do we decide how many of those zeros are significant? Okay, there's two ways. One, right here, completely bass-backwards BS, I defined it. I said 3 zeros are significant. How do we do it in the real world? It's the device you use to make the measurement. That's what dictates those sig figs. Okay? We don't know what device, I just made this number up. We don't know what that device is, so we can't really say the device told us that. So I have to arbitrarily step in and say, I want 3 sig figs, or 3 zeros to be sig figs. It has to be those 3 because of the rules of sig figs. Okay? So to your initial question, why did I pick that? Well, I picked that so that this number looks more interesting. When I convert into scientific notation, I don't have just an 8 chilling there by itself. I can show that those zeros now actually have meaning and they show up in my sig figs. Because in my standard notation, there's nothing that differentiates those 3 zeros from any of the other 3 zeros. I have no idea if they're significant. This scientific notation, now I know absolutely without a doubt. Does that make sense? Okay. So the short answer is I defined it, that's why. You could ask a question about why I defined it, and that's a little bit less important. Yes?
Could you put like 2 zeros after, or would that be wrong?
So there's a question. I like that question, so let's define that. Okay. Working again within the context of what I have said. I said 3 zeros are significant, right? We all heard that? We accept it. So the question I believe you're asking is that if you wrote, would you be correct? Right? That's the question you're asking? Okay. What did I say about the zeros being significant? How many? 3. Did you write 3 zeros?
No.
So are you right?
No.
No, you've broken the system. You've now decided to not listen to what I said was defined. Okay? Could there be a different problem where only 2 zeros were significant? Yeah. Okay? So you can change the problem set to make that true. But if I'm the one writing the question, you can't change anything. That's me. You follow my rules. Make sense? Okay, so we had 2 questions. You guys get both of your questions? You're okay with it? You had a question too? You're good with that?
Okay.
Follow on? Okay. So let's delete this one. So cool. We got scientific notation. Generally speaking, scientific notation isn't as challenging because you aren't looking at random zeros. You actually have digits 1 through 9. Okay? The vast majority of cases that you are going to work with, okay, through any of your calculations, you're going to be using digits 1 through 9. So those stand out as more clear, significant digits. It's the zeros that become challenging, which is why we push on the zeros more, because they're harder to grasp as an understanding. We good? Okay. So that, I would argue, is scientific notation. Should have picked a different number, and we'll see why here in a second. Because you had to kind of follow along with that, is you then went through and said, well, what if we add units? Okay, so let's add grams. So we were looking at 8 trillion grams. Okay, we dealt with the scientific notation. Joel Spin, again, I don't think your question was actually about scientific notation. So what we've got is this now measurement. 8.000 times 10 to the 12th grams. Okay? And now we as scientists or people can look at this and be like, well, is that a number I'm comfortable with understanding? Okay? Said another way, if you wrote out the full original number, good thing I erased it all, right? Okay? Did you enjoy that process of writing all those zeros? Were you like, yes, thank you, Mike, please keep writing problems like that? Or are you like, I'm not writing that example down, this is a stupid example? It was a stupid example. Okay, that's the point. So we aren't happy with all those zeros. Okay? This notation of converting it into a power of 10 is better because I don't have to write as much. We're lazy. But now we want to push a little bit onto the meaning. How well do we do with powers of 10? Okay? Said another way, what is 10 to the first power? 10, okay, not bad, good. 10 to the second power? 10 to the third. Fourth? Fifth? Sixth? Seventh times eighth? Oh, dang, he just broke. Okay, so our ability to manipulate powers of 10 is pretty shoddy. Okay, and because we have a shoddy ability of it, what we do is acknowledge that we suck at dealing with powers of 10, and we create a system that allows us to ignore the power of 10. What is that system? I'm going to say if I see 10 to the 12th, then I'm going to... Does anybody know what 10 to the 12th means? Tara. Okay, thank you. Then I'm going to say 10 to the 12th means capital T. So what I can now do is rewrite this whole number, because everything we do is about rewriting numbers, and write it as 8.000 capital T G. Why? Because I don't like powers of 10. That's it. I don't like powers of 10, so I invent a symbol so that I don't have to write powers of 10 anymore. But this means I have to know what that symbol means, which is, I think, your question. Okay? Are you responsible that if I gave you this thing, that's an arrow going the other direction, can you tell me what that number is? And some people are like, yeah, of course I can. It's 10 to the 12th. Okay, cool. Fair game. Capital M. What's that one? Show off for whoever said the answer. Okay. I just heard there was one that was 10 to the 6th was the capital M, and now we're a cursive M, and I'm hearing 10 to the 6th again. That's problematic. We can't use the same symbol to mean different numbers. Okay? And that brings up a whole another caveat of issues of dealing with conversions, which I don't think I push too much at this point. I think what we're going to do is just kind of address how do we represent these numbers and minimize dealing with conversions for the moment. And then we'll step back into, okay, now you can do measurements. If you're happy with lab, do the measurements in lab, and let's talk about atomic structure. Okay? But your question is how many of these symbols should you know? Okay? Because as we started to address, there was capital M, there was capital T, there's a a cursive M, okay, a lowercase m, an N, an F. Oh, there's a K. I know there's a K. Let's do a K. Okay. How many of those are you responsible for knowing? And for the record, I barely scratched the surface because I don't know very many either. Shouldn't have recorded that. how many you responsible for having memorized?
3, right?
3. Yeah, what were the 3? Kilo, centi, milli. Okay. Lowercase k, lowercase c, lowercase m. Okay. Why are you responsible for knowing those 3? Someone said something? All of these prefixes are based off of actual measurements. There we go. Okay, these are going to be the most common measurement unit systems that you would see. So if we're going to measure length, we'll probably be measuring in centimeters. Okay, why not millimeters? Because they're too small. I don't want to measure millimeters. Well, we'll use a ruler, and the ruler, why don't we use inches? Because inches is too American, and we're un-American scientists. I don't know. Okay, that's just kind of the default systems that we move into. Why use milli? Okay, well, we typically use milliliter. Why do we not use liters? Because if I asked you to mix 2 liters together to run a chemical reaction, the scale of that chemical reaction is going to be so large that it's probably going to be dangerous. Never mind the fact that you're now holding on to just a liter chemical bottle. That's dangerous in and of itself without even mixing them. So we want to drop the scale down. We want to drop the scale down to milliliters, which is now a significantly smaller volume. Safer for you. Okay? So these are your most common units. Kilo, interesting one, you're not going to use. Why do I want you to memorize? Okay. The why has to do a little bit with the meaning of each of these.
Use it in medicine?
That's fair. You do use it in medicine. So sometimes I could throw in conversions. A lot of students moving through here go through some nursing type program, and you'll use kilograms for patient weight for figuring out dosages. So it makes sense to bring up the kilo there. For what we actually do here, you're not working with kilograms of anything. Okay? But what you would do outside of the class, a large portion of this class is going to deal with the kilogram unit. Okay? But that's not why I chose it. It would be a good reason to say that's why I chose it. I didn't choose it that way. Why is kilo something that I want you to realize? Well, what does milli mean? What did we say all the prefixes represented? They represented powers of 10. Okay. I love that you said that, and you'll be upset in a second. Okay.
Or 10 to the negative third. Sorry.
Oh, there it was. It already slipped out.
Damn it. Sorry.
Okay. Milli and kilo are actually tied to each other because they are very, 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 very similar in their intents. Okay, if you look at the powers of 10, I can't even reveal it slowly now. Milli means 10 to the negative 3. It's a small number. Centi is 10 to the negative 2. Again, small number. Kilo is 10 to the third. Kilo and milli are very closely related because they use the same number, but they use a different magnitude of that number. And depending on how you set up your conversions, you may have been told to memorize certain things about what milli means. Okay? So since we're here, we've already started that bridge walk, so let's start that cross. If I look at 1 kilogram, what does that equal? Okay, 1,000 grams, I'm actually going to say no, I don't want that. It says 1, and then what does kilo mean? Times 10 to the third grams. However, people that are good with math and all that, that's great. You can say, well, 1 times 10 to the third, Mike, is 1,000. I completely agree. That's fair. But for the sake of this argument, let's ignore that. Okay? What is 1 centigram? My hand's getting wild drawing all these trace things. What is 1 milligram.
1 times 10 to the negative 3 grams.
Why does that matter? Okay. It matters not in this notation, but what matters is how you're told to memorize this information. And if I ask you to tell me the relationship between milligram and gram, you made the mistake, so I'm going to push on you a little bit and see if you've got it memorized this way, which is okay. What did you memorize for milligram and gram conversions? We'll see. You may not have it. That's fine. Have you got anything? If I asked you to convert milligrams to grams, what would you tell me?
It was 10 to the negative third. I don't know. It's
Right?
like in the
That's so this becomes important. Okay. Did anybody else memorize anything? Remember we walked through this. If I want to convert milligrams to grams, anybody have something they've memorized for that? As hard because we don't even acknowledge that we've done this memorization. If you talk to, I always throw biologists under the bus, so we'll continue to do it. Talk to a biologist, they will tell you 1,000 milligrams is equal to 1 gram. Are they correct? 100%. Is that 10 to the negative 3? No. 1,000 is a large number. Where did the 10 to the negative 3 go? So let's back it out because I erased it. Who's right? Red, what you've been told and manipulated before, versus what I've written in black and red. What's that? They're both right. They're both 100% correct. It's changing where you're placing the numerical value. Can you move a number from one side of the equation to the other? Yeah? How? What? Oh, yeah. Okay. We can move the number to the other side, okay, leaving kind of the unit behind by doing a division. I can divide both sides by 10 to the negative 3. I can divide this by 10 to the negative 3. Okay? Why would I do that? How many people like powers of 10? Okay, question. Well, how many people like negative numbers? Don't look at your bank account. Okay? So if we look at the notation I'm telling you to work with, you're like, this notation sucks. I have to deal with two things that I do not like. I get it. And if I listen to the biologist, I'm happy with a positive 1,000 in my bank account. That's okay, depending on where we're at within the month. That could be good. Right? Then why do I have a problem with this memorization? Well, what do they tell you for centigram? They'll tell you 100 centigrams equals 1 gram. Right? Like, Mike, this doesn't make any sense. Why are you complaining? What's kilo? Where do you place that 1,000? A 1,000 kilograms is 1 gram? Ooh. So the problem with this memorization system is that your power of 10 moves locations. It is tied to a different unit. So if you're memorizing that 1,000, great. Okay, you're memorizing that 1,000 needs to go with milligrams. You go, okay, powers of 10 need to go with a complex unit because there's two pieces to it, right? But if we go up to kilograms, does the power of 10 maintain its same location? No, it's changed. So not only are you memorizing the number, you are also memorizing where you must place that number. If you're good at that, by all means, go for it. Guess what? You're not. Okay? I've written several test questions that have proven this. People are like, no, I'm so good at it, it doesn't big, and success rate falls through the floor because you swap where you place those numbers. Okay? Up to you to decide how you want to do it. Both systems are perfectly valid. It comes down to consistency. This, you have to deal with powers of 10. Am I asking you to deal with powers of 10 in your head? No. You have a freaking calculator. Use it. You know what this came from? That came from an era that had no calculators. Okay? This was a process of I can't deal with powers of 10 in my head, so I'm going to convert the numbers around into a system that's easier for me to manipulate. But you had to memorize more information. Less information, more complex. Learn how to use a calculator, you don't have to worry about it. Make sense? That's the give and take between those two systems. Okay? So, to your statement, complex units. I expect you to memorize kilo, centi, and milli. Okay? KCM, however you want to memorize it. We can call it the left method and the right method. You can even call it biologist versus Mike, because nobody listens to me anyway, so I'm really just off on my own. Okay? Are you responsible for using the other complex units? Yes. You are absolutely responsible. You need to be able to go, oh, it's a teragram. What the heck did tera mean? Blah, 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 blah. Tera meant 10 to 12. 12? Is that what we said? Yeah, good. Tera meant 10 to the 12th. I want you to spend the time to look that up and manipulate it and use it. I will not ask you that on an exam. Right? But I do want you to have that practice. So, homework, open game. Yes. Manipulate it. You're just expected to look it up. Make sense? Okay. I talk too much. Are we good? Cool. Next question.
It's milliliters, right?
So milli is just a prefix unit. It could be appended to milliliters. It could also be appended to milligrams. It could also be millifeet, which is a really weird one because feet typically don't go by powers of 10, but you could still have millifeet. Milli can be added to any measurement system, any single one. Milli will always hold the same meaning all the way through it. It means 10 to the negative 3.
And same for the other ones. Yeah.
And same for the other ones.
And how do you spell milliliter? Is it Leter or Liter?
American versus British, doesn't matter. I don't care. There might be actually more to it now that I think about it, but I usually spell it Liter.
Spell milliliter.
Yeah, don't stress. I won't complain about spelling.
You know what it is though? Is it Liter or Leter?
I spell it Liter per liter.
And then the CG, the hundreds, is that centi? What is that?
Centi.
Centigrams?
So yeah, CG would be centigrams. So when we look at those, we tend to assume those are some fancy new unit. It's not really a fancy new unit. Milli is a prefix that gets rid of the power of 10. And then the other one is what I call a core unit. Okay? It's a single measurement system. So grams, liters, gallons. Okay? And then it's how do you adjust or modify that unit. So that's what that prefix is.
Whenever we're solving an equation, should we, or like, do you like want us in our explanation to like write the 1 kilogram equals like 1 by the 10 to the third, like so that it's like, so you know that we know it? Do you want that part of like the answer to our question? Am I saying that right?
This is now starting to move into that kind of conversion system. If your question was convert 2.3 kilograms into grams, how should you format that? So that's a slightly different system, okay? And we'll push on that eventually in a lot of kind of gory detail, okay? But in that question, as simply as it's written up here, what you should do is follow kind of a regimented step sequence. And as long as you follow the same step sequence for every conversion, you get used to that process and it becomes straightforward. Okay? The process that I show, a lot of people will call the railroad tracks. I think of crisscross, there are different names for it. But it's ultimately the same thing. Okay? And what it comes down to is the order in which you do things. So the first thing before you start any problem is you need to figure out what the problem is. Okay, that needs to get identified. Okay, so in this case, what's the problem? I want to know how many grams I've got. Okay? This is going to involve some kind of mathematical calculation. Mathematical expressions usually use an equal sign. Okay? Typically, when we talk about mathematical expressions, we usually do the answer on the right-hand side, and all of our work is on the left. It's up to you. That's entirely arbitrary. You can come up with any system you want. Okay? For the methodology that I use, I would put the equals, and then I would put grams. Okay? Now, my whole task is to look at what I'm given, that's everything on the left-hand side, and say, how can I make the left-hand side look like the right-hand side? Once I've done that, I can manipulate all my numbers. Okay, so this is now all my given information. And given information can get a bit dodgy, because sometimes given information is that's fair. Memorized. Okay? So for this case, to solve this, showing all our gory, detailed work, you had to have some information memorized. So what information do we have given? Okay, cool. And I love how you said that. Okay, and I'll record it in. The response to that was 2.3 kilograms. Okay, and my response to that is going to be, unfortunately, no. My response to that is, you were given kilograms. The number is insanely misleading, because what we do is we overemphasize the number and we lose track of the meaning of the units. The units are what drive this. Okay? So now what do I do with those units? Well, I have to place that given unit of kilograms somewhere on the left such that it can match what's on the right. Okay? And one of the reasons why we bring in railroad tracks is in both the left and the right, we have fractions. We have a numerator and a denominator. So if I go over to this other side, I still have a numerator and a denominator. So I now need to know where to place the kilograms. Well, what is kilograms a measurement of? Except grams, but what are grams a measurement of? I'll accept weight, that works. Okay, mass was the one I was fishing for. So if I look at my answer, I want grams, a measurement of mass, found where? Numerator, denominator. Numerator. If you don't like numerator, top and bottom, that's fine. I want it in the top. I go back to my given information, I've got kilograms, which is a measurement of mass. Where do I want my measurement of mass to appear? In the numerator, or on top. So I'm going to put kilograms on top. Do I know a number, well, we didn't even have to do that. Is there another unit associated with this number in my given information? What's the other unit written in that black box? I specified kilograms. What's the other unit other than kilograms? That's not grams, that's kilograms. What's the other unit specified in that box? And if you're really struggling to answer that, that's because you're trying too hard. What's the other unit written in that box? 2.3 is not a unit. A unit is a measurement system. Grams, time, or seconds, hours. Do you see kilometers? What's the symbol for kilometers? KM. Do you see KM written up there? No. Do you see seconds, minutes, hours, days? When does Mike stop talking? Then, that was actually it. What other unit is written in that box? Nothing. So don't put a frickin' other unit in it, because there isn't one. What number is associated with that 2.3? Number written with the kilograms. 2.3. Okay, where is the 2.3 written? Is it written above kilograms or next to kilograms? Next to, which means when I go to the given information, where should I place that 2.3? Next to. What do I put in the denominator? What did you say? 1 or nothing. Okay? Nothing is okay as long as you're implying it's a 1. You can't imply a 0 because 2.3 divided by 0 is a problem. I don't want to put anything in that denominator, because if I put any numerical or unit value, I'm changing the given information. Does that make sense? Cool. So 1. Times now what? Is kilogram the same thing as gram? No, they're different. So what has to happen to the unit of kg? Okay. So I'm hearing some multiply and divide. No. What has to happen to the unit of kg on the left-hand side of the equation? It has to be eliminated. Ooh, eliminate. That's a lovely word. I was going to go with canceled, but eliminate is more fun. I must eliminate it. Well, the kilogram unit is located where on the left-hand side? On the top, which means where do I have to place the kilogram unit to eliminate it? Bottom. Okay. Is that all I want to do? Just eliminate kilograms? No. Okay, what else do I want to do?
You want to cover it in grams.
I'm going to tweak your language a little bit. Okay, if I eliminate the kilograms, that wouldn't get me my answer. What else do I need? I need grams to appear. Where do I need the grams to appear? In the numerator. So I would like grams to appear here. What I have now defined through the process of thinking through what things are happening here is I need a conversion factor. A conversion factor relates one unit to another unit. That's exactly what's in this expression. Okay? So now I have to ask the all too fun question, do I know a conversion factor that relates grams and kilograms? Okay? Depending on what you have memorized is up to you. Okay? My argument is you memorize power of 10 with the core unit. Okay? Kilo meant 10 to the third. The core unit here is grams. So the power of 10 goes with the core unit. What goes with the kilogram? 1. What happens? What happens to the kilogram unit in the numerator and the denominator? They cancel out. What unit would I be left with on the left-hand side of this arrow? Or equal sign. Thinking OChem. Grams. What did I want? Grams. Do I need to do any more calculations? Nope. Now I can bust out the calculator and I just deal with the numbers. I can say 10 to the third times 2.3. And for those people that were like, I could have done that in my head, Mike, I totally get it. That's fine. You can. Okay? The point of making you do these kind of conversions isn't to prove that you can do the conversion. The point is that you can do the conversion process that we just walked through. And you were like, this process sucks, Mike, I don't want to do it. Okay. When we move to units that you have never dealt with before, and you're like, I don't know what to do, these units don't make any sense. Yeah. Do you have a process that allows you to manipulate it without understanding the units? You're like, well, no, I didn't learn that. Yeah, you did. You did. Here it is. That's the process. The process sets you up so you don't have to know what the units mean. Should never record that, but whatever. I'm telling you as a chemist, I don't care that you know what a mole is. I care that you know how to use it. Okay? And for the people that only need this class, you don't care what a mole is either. What you care is what's the process that you would use to convert units that are complex and weird. The process will hold for every single conversion. It's obnoxious. Just like me. Do you want to put that rabbit back in the hat? So, what would I expect? That's what I would expect. That's what I would want to see. Show me that work. Okay? I have seen people try and do arrows and things like that. I can track what you're trying to do. Usually that process breaks. It does. Okay? And it breaks around units that you don't understand. Okay? Or it breaks around numbers that are so absurdly large or small that you don't know how to manipulate them. Okay? This process works. When? Every single time. That's why it's so annoying. Did I answer your question?
Yes.
Am I yelling? Does it feel like I'm yelling? I'm not angry.
Enthusiastic.
Yeah, let's go with enthusiasm. Energetic. Okay. Next question.
So,
Oop. Is it a follow-on?
I was just asking about the 10 to the third. So
Okay.
place that there because kilo represents 10 to the third.
So when I look at the conversion relationship between grams and kilograms, what I have memorized is that kilo means 10 to the third. And that my power of 10 will always go with my core unit. That's following Mike's process that we had on the right-hand side of the screen. That does not follow the biology process. The biology process requires that you memorize more. One of the most irritating questions that I hear at the tutoring center all the time, I've asked it too, well, which is bigger, kilogram or gram? Well, as a student, really, if you knew the answer to that, you wouldn't have asked the question to begin with. It's a stupid response to students not understanding it. Right? So it's how do you memorize, where are you putting that information and processing that content?
I was going to ask if the 2.3 kilograms, if it was in scientific notation, if it was more than 2.3 kilograms, would you convert it to standard before you do the other conversions, or would you keep it in scientific?
Okay. So the question is if we were in scientific notation for that number, would I convert that number into a different measurement system? Do I need to? Does changing the number change this process at all? Absolutely not. Okay. So there's no need for me to convert that into another system. Why would I convert it into another system? Maybe I didn't want grams, I wanted centigrams. That's why I would convert across. Okay? But only then. I would avoid doing any kind of manipulation of that number unless I was forced to do it. Does that make sense? Okay. Which is an awesome question, and what that's coming back to is an over-reliance on numbers. I'm not saying you generally. We all are overly reliant on numbers. Okay? The fun example I like using is I'm a 6. What does that mean? Okay, someone was like, oh, that's your height. No, that's my dress size. Does your interpretation of that number now drastically change? Whoa. So you mean the number held no value until we brought in the unit? I actually don't know that to be true, for the record. I think that's what I've tried before, but I don't know. I honestly don't know. I don't remember. College is fun, you know. Any case, was that recorded? What's next?
I just had a question about one of the assignments. For the topic chosen, well, I guess it's not a question, it's a statement. The writing assignment directions, that's a dead link, it doesn't work.
Oh, that's something I did. Oh, excuse me. That did pop up. I did see that, and I just haven't had time to go back and figure it out. What I've been waiting for is someone to yell at me, so I knew where to dig for to find it. So we'll point that out. Excuse me. So first and foremost, where is it? Is it week 2?
Yeah, it's week 2. It's right.
Oh, right at the top. So for some reason, sometimes Canvas brings things across and sometimes it doesn't. Okay, ooh, I just figured out why it doesn't. Neither here nor there. I'll fix it in a second. Okay, the link should work, right? Was that working?
The bottom one does, but the top one
Yeah,
is
okay.
the directions.
So the link to assigning it, and I'll talk through the directions real quick. The link to assigning is there, so you would just write your name into it. What are the writing assignment directions? We have a writing assignment that is broken across, I think it's 4 things. Okay? What I want you to do is effectively pick a topic that you might find interesting. Okay? So the elements tends to be a standard one, but if you're flipping through the textbook and you're like, oh, nuclear chemistry, I want to study nuclear. Okay, fine, do that. Okay? Find a topic that you find interesting, and I want you to do a little bit more digging into that topic. Okay? So that's the topic availability. And I don't want 30 papers all on hydrogen. Right? I want it to be a little bit more scattered, which is why it's only one person per thing. Make sense? So you just put your name in, make sure you hit enter, because that's happened a couple of times. People have typed their name, and it's still got the cursor, and then they close it. It didn't save. Write your name, hit enter, make sure your name is actually locked in there. Yeah. Okay, so what you would do, topic chosen is the first part. You just pick a topic. 5 parts. I think 5 parts. The next one that comes up is I want a 200-word, why'd you pick this topic? Right? I'm not looking for anything crazy. I'm not counting words either. I just want you to spend some time to be like, well, why did I do this? And if you're just like, roulette, okay, you can tell me that, but at least open up the Wikipedia article on whatever that is and write something that showed that you did some thought process behind it. Okay? After that, we have the fact sheet. So in the fact sheet, what I want you to now do is organize some content about that topic into a fact sheet. Okay? And by a fact sheet, you've seen people on the streets, right? Like handing things out. Okay? Your goal is that if someone walks by you and you tried to hand this to them, they would take it. Right? So if you've seen people out there and it's just a white sheet of paper with just a bunch of words on it, are you taking that? No, you're probably like avoiding them as you walk by. So fix it. Okay? Make it look like someone should take it. Within some reason, I can see some massive problems with that statement, but it should work. Okay? Now provide some information about it. You've now hooked someone by making them want to look at it, give them some information about whatever that topic was. That's the fact sheet. Then really the last part is make something creative about your topic. Okay? Where it's gone in the past is stories, if you want to do writing. If you want to do an art project, do an art project. Right? You want to do a poster, do a poster. Right? But the idea is to, again, bring the topic of what we've covered at some point throughout the semester to life so it's a little bit more real for you as a student. Okay? That's the very end thing. To encourage you to be working on it before the last night, there's a draft assignment too. Okay? Like 3 or 4 weeks before the end of the semester. The draft is just a draft. Okay? You sat down one night at a restaurant, you're like, oh, there was a stupid writing assignment for chemistry. I was supposed to do something about hydrogen. God, well, this is what I think I'm going to do. And you're just writing down on a napkin. Show me a picture of the napkin. That's fine. I don't care. It showed some initial thought towards creating a project. Make sense? Does that help? Mm-hmm. Right. The writing assignment directions is kind of more important because it does have some examples in there also with letter grades that were tied to them. Right. So I do need to get that in there. Yeah, hopefully I'll do that.
But for only this part of the assignment, we're just.
Oh, this part is just you write your name next to an element or topic, or you find a new topic and you write your name on, provide the new topic and your name.
And then you said this is continuing throughout this semester.
It continues throughout the semester, so you get periodic assignments. And if you get real punchy and really want to know what's going on when, the writing assignment directions do tell you once I fix that. But what you could do, anybody get sick seeing someone scroll? If you do, stop looking.
Okay, back up.
Oh, you saw it? Oh, the 200-word report. There it is. 200-word report. There's one. That was week 4. Okay? Same week of the exam. Yeah, do it after the exam. Chill. Some thought. And then the one I was looking for hovers around week 8. There it is. Flyer fact sheet. Around week 8. Okay, and then I think we hit draft. There it is. Draft in week 13. And then the final one, I might have moved the due date up because people keep trying to turn it in during finals week, and that's kind of irritating. But I'm fine with it coming in during finals week. It's just having 40 of them swamp me. Week 16, particularly if they're art projects, I might force you to help me drag it to my office. Make sense? Does that help?
Yeah, that was helpful. I also was wondering about the practice tests.
Yeah.
Are those like the same content that's going to be on the tests, or
like the exact same thing, or if they're just to help the same type of questions?
Content. So if we open up the open edit, so one of your kind of things that might lead you to exactly those questions is that if you open this up, oh, thanks, Josh Davis. Okay, is it says read the directions. Okay, so it's got this stuff. This is the first page of your exam. It looks like this. Very similar to it. It's not 100% the same, but it's pretty close. Okay, and then you get table of all the conversions, so you know what you're going in with. You asked about what things to memorize. Okay, I don't expect you to memorize, oh man, it's there. I don't expect you to memorize the capital T, but I do expect you to use it when I tell you. Okay, so it's given to you. That means you could use it. It also may mean absolutely nothing. It's just there for the hell of it. Okay. Periodic table. We can't print in color very well or efficiently, so this one has the key kind of at the bottom with the different phases, okay, tied to those elements. Okay. Our periodic table, this won't be down during the exam, but the periodic tables up here, both are color coded. This one has it coded. And then we have short answer. You'll have, I think it's no more than 5 is the rule I hold to. 5 short answer. Could it be these exact questions? Yeah. Will it be? Probably not. Okay. But if you've answered this question, could you be successful on it? Yeah. Okay. Realize, okay, have we addressed the fact that I am very short on time? Like just overall this semester? Yeah, it's pretty miserable. Which means I don't have a whole hell of a lot of time to do a whole bunch of modifications. So when I go through to put together an exam, what I want to do is start with something that's mostly built and say, how can I tweak this fast? Kind of, sort of? Cool. Based off of where I think you're at in the videos, a student noted that the atomic radius decreased through a family. So did you watch videos about atomic radius? Some head shakes, yes, cool. Okay. On the periodic table, which direction did they move through the table? Okay, this is a fun one, right? So I was kind of waiting for hand gestures. Okay, the only hand gestures I got were this direction. Okay, but the fun part was, is I got some people going this way, and I got people going that way. Ooh, interesting. Okay, and I got somebody going down, which is not either of those at this, right? Which encounters a new issue. We've got our grid pattern. We can go left, right, okay, and we can go up, down. Right? And if we're talking about atomic radius, the radius changes both left, right, and up, down. So how do you know which direction you should be looking at? The word family. Are you responsible for knowing what family means? Yep. So what you would have to do is not just say, oh, it's decreasing this direction, but also acknowledging what a family is. Well, the family is up, down, also known as a group. Right? And for people saying group, that's awesome. I appreciate that you know the actual word, but that's also not useful if you don't know what a family was, right? Right? So there's different words that we can use to represent those things. So that family tells us we need to look at the up-down. Where is it going to decrease? When does the radius get smaller as we go down or up a column? Challenging. What dictates radius? Right? Circumference, good answer. What makes an atom? Protons. Neutrons, gotta be careful with that one. Electrons. Cool, there's 3 things that make up the atom. Which of those dictate radius? Where are the neutrons? Inside the nucleus. How big is the nucleus? Itty bitty 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 bitty. And if it's itty bitty bitty bitty, is that what's dictating the size of the atom? Nope, so neutrons are off the list. Okay, so we get electrons and we get protons. Where are the protons? Inside the nucleus again. So again, probably not dictating the size of it, which leaves us with electrons. Electrons are the primary driver for our radius, how big the atom is. So what happens to the electrons is we go up or down the column. Take a pick. First you got to define which direction you're going. Okay? If we're going down the column, ooh, that's interesting. So you've memorized the trend, but then the content on the y you're struggling with, which is interesting. Right? So it gets bigger as we go down. Why does it get bigger as it goes down? It says explain the trend. Right? Well, if electrons dictate our size, what happens to the electrons as we go down the column? The amount of electrons increase. And the more electrons you put around something, what would you expect to happen to size? It should get larger. So if it's decreasing through the family, which way did they go? They went up. So the whole arrow's pointing left and right and pointing down. All of those were wrong. It was all going up. Right? Yay, don't you love that? Right? Slow it down and process through it. It's okay. So it goes up. Explain the observed trend. Right? Why does it get smaller as it goes up?
Because the number of electrons.
We have less electrons. Right? Perfectly acceptable for this, but now let's flip it on its head. I want to write a new question that covers this content, but I don't want to ask the same question. What do I do? There's no numbers. Decreased becomes increased. Ta-da! Spun now on its head. Do you understand where those trends are going and why they're going? What else can I do?
From family to a different term.
Yes. I could change the word family to a different term, changing where the location is we're now referencing. Make sense? Right? So when you go through and do the practice exam, yes, answer the question. That's the place to start. Now what you've got to do is answer the concept. If you can answer the concept, it doesn't matter what I ask you, you're covered. Does that make sense? Right? When should you do that whenever you're given practice exams? I asked the question wrong and I knew it was wrong in my head as I said it. But, okay. Think about all your other classes when they give you a practice exam. Are you just answering the questions? Or are you answering the content? Okay. I would argue 9 times out of 10, based off of feedback I get from people with saying about practice, oh, it wasn't the exact same. Of course it's not the exact same. Okay. You're doing the practice exam wrong, which could mean you've been trained wrong by bad teachers. Sorry. Or good teachers that don't have time. Okay, let's go with that. Okay? You should always be addressing the content when you answer a question. The only time you care about getting the answer 100% correct is on the test itself. Then we don't care what the content is necessarily. Did you get the answer right? Okay? If you've mastered the content, you'll get the answer right. Make sense? Cool. I don't know why the question is duplicated. It seems a little bit weird. Okay, but this is the open document. Right? It looks like someone came in and said they moved left because that is the opposite of right. Okay, well, was that up? The answer was up. It moved left, so that's wrong. Right out of the gate. And does that explanation make any flippin' sense? No. So I will come in and I will chime in with a little Mike says, and Mike says, this isn't good enough. You could be right, but your explanation is so messed up, I'm not even going to touch it. So I won't verify whether you're right or wrong. I'll just say you need to fix your explanation. When your explanation is fixed, I will come back in and I will adjust. Where should you provide your fixed explanation? This is an interesting question. I would argue underneath my comment. Don't adjust the original comment or the original submission. Okay, and there's a couple reasons for that. If you're trying to learn someone's process on how they went through and thought through things, you should see how they thought through it, as opposed to just seeing the answer and being like, hooray, oh, all I gotta do is memorize the answer. That's not how it works. Learn how someone screws up. Right? And if you're like, I don't want somebody to see I screwed up, your name's not tied to it. The only reason your name is tied to it is because you go in and you say, Joe said. Dude, don't put Joe. Just write an answer and you're fine. Make sense? Cool. Did I answer your question? And then something? Like beat it?
I actually did that one.
Yeah.
And we can use the
written homework, anything you put into this document is absolutely fair game. You can use the practices test. Right? There's a loophole there in the written homework that I'm not going to elaborate on, but just happened to process that recently. Okay, but you can absolutely use any of your work for working through the practice exam for the written homework. You can use the active homework. You can use the textbook. All of those are fair game.
And that's the paper.
That's the paper homework.
Okay.
Yep.
Use it written on
Yep. And so the first one, there's a lot of grace, okay? But I'm going to guarantee about half the class is going to come up with these weird questions of like, what is the name of the element that begins with AT? And it's clearly something that you are writing. Okay? That's not the point. It's okay, but that's not the point. The point is to find questions somewhere else and provide explanations for how you would answer those questions. Kind of get it? Next.
Reading journal 2 is our first reading journal.
Yes.
That literally just means that when you're reading those chapters, it just summarizes.
So the reading journal, you should see in Canvas. Okay. I will fully disclose I think the due date is bad. Okay, because the intent of the reading journal is you're reading ahead of the lecture. Based off of where the due date is located, you're actually reading behind the lecture. Okay? I did it this way and I'm sticking to it. Okay? So the point is that I'm trying to make you open the textbook. Open the textbook and see that other people can talk about this content as well. I don't say everything the textbook says, and I definitely don't say it all the same way. In fact, I vehemently am against some of the things the textbook says. Right? But reading the textbook can bring in another viewpoint that can help you learn the content better than just listening to me. Right? So the whole point of the reading journal is to provide some reason for you to hopefully crack the book and look at some words. The reading journal is evidence that you did that. That's it. Does that make sense? It wasn't you, it was you. Long
my
mind.
question, but you
PSS .4, does that just mean all of them?
So yeah, the labeling system, so if it says PSS .4, so what it is chapter section. So when it says PSS .4, I'm saying PSS chapter because the textbook decided to call it PSS, section 4. So if I say PSS .4, I'm not saying read up to .4, I'm saying read section .4. If I say PSS .4 dash .6, now I want you to read from .4 to .6. Does that help?
Sorry.
No,
I
go
still
ahead.
don't know what PSS means.
PSS means
Is it
prerequisite science skills. It's the name of their chapter. Why they didn't just call it chapter 2 and just adjust all the numbers is a good flipping question. That's probably for the 9th edition. Actually, if you look backwards, that was the difference between the 5th and the 6th edition, is they took chapter 2 and they made it PSS. That was it. New edition. Yay, more money. Next.
This more questions. Somebody found the book for free. I just don't remember where they found it at. I don't know who said it. So.
You just type in the book in the PDF and it comes up.
Oh, okay. Thank you.
On the play posit, like I open it up, but I type in the video and it never shows up, so I just watch it on YouTube. Like, how do you use play posit?
Come on, cursor. So, using PlayPosit. You click. Right. You can sign in within Canvas, or you click the click here to link to the software. You click there, it'll make you sign in, and then guess what it takes you to? The video you need to watch. That's how you use
You
PlayPosit.
just watch it on YouTube?
So awesome, you can absolutely watch it on YouTube. Do you get to answer any of the questions that are in PlayPosit? No, which means you get any credit. No. So you can absolutely watch within YouTube to get the content. You just won't get any of the credit for having done it because I can't see that you did it.
Okay, so say again, you click on there and you log in, and you're supposed to be able to get in there, and then how do you search up the video?
What do you mean search off the video? You click it, you sign in, poof, it's the video. You click play. That's it.
Try it again.
It's to the play pilot as well. So is it every video that we, because like some of the videos when I click on it, it takes me to YouTube, it doesn't take me to play pilot.
Yep.
Is that,
That's because if I made a play pause it for every single video, you would literally hate me.
oh, okay. Yeah, because I know like.
So if we look for week 1, you have 3 blue links that say lecture. Those are just YouTube videos.
Okay.
Those are YouTube videos that cover that relative topic. So that very first one that says Lecture 01, that's science and matter. I talk about what scientific theory is and then what matter is. That's it. Okay? Lecture 2, atomic structure. Now I go through the basics of what builds up atomic structure. Right? Lecture 3, isotope weight and averages. Talk through all the calculations on how you would deal with isotope weight and averages. Lecture 02 and PP, note, the color changed. Why did the color change? That's an assignment. That's something that's actually built into Canvas. Not deciding whether it's an assignment or not, you could look at a little green icon, but that little writing, drawing thing means assignment. That's when you do play pause it. That is the only time you do play pause it. Those other lectures, there is no play pause it for. Does not exist. Right? Right? You're responsible for watching those. There's just no tracking that you've watched them.
And then when we do the play pilot and will automatically show on the side, or do we have a screenshot? Like,
So that's a good point for tracking. Okay? And this appears to not be necessary anymore. But if you go through and read this thing, it goes through that you'll see a completion screen at the end of watching that video, and you should screen capture that and email it or submit it into the assignment here. Right? Is it necessary? Absolutely not. You do not have to do that. But if for whatever reason you've done it and PlayPosit doesn't track it, you're SOL. You do it again. Right? But if you've got that screenshot image of, hey, I did it, look, see, my name, completion, I'm done. Now you put it back on me and say, okay, PlayPosit lost it, not me. I did my work, give me my points. Okay, you win. It's creating a defensible position to get you credit. If you do it, that's fine. You can submit it. That'll also turn off Canvas, because Canvas will give you alerts about it. Okay? The week of the exam, I go in and download them all, and I manually adjust to put in scores. And so the week of the exam, you'll see all of those scores update for any PlayPosit up to that exam. If you're curious what your score would be ahead of time, you can send me an email and I'll do a quick scan through and be like, I bet you got perfect. I bet you got 9 out of 10.
What does the completion screen look like? Because I just heard
It's a little circle thing. It's a circle thing with a number. It says, hooray, you got it. It usually gives you a score. And that score is miserable.
And that's on YouTube?
It's not on YouTube. That's PlayPosit. It's all through PlayPosit. Anything involving quiz questions is PlayPosit, not YouTube. YouTube doesn't let me do jack. It's all through PlayPosit.
If you do the play pause it, but you weren't satisfied with some of the content you were attempting to learn, could you redo it and resubmit?
Can you redo PlayPosit? Absolutely. You get the highest score. You can take it as many times as you want. If you're unsatisfied with what PlayPosit spit out, what could you do? Number one, you could retake it. But more importantly, what should you do? Come to class and be like, dude, Mike, this sucked. I don't understand how to do this question. Help me. Okay, there we go. We'll start that conversation and we can start to break down those parts where you're having struggles with the material. Yes, sir.
So the actual score of PlayPosit won't.
Is utter nonsense.
I was rewatching them to get those.
And yeah, you can absolutely rewatch them to get better scores. All sorts of hacks. I'll let you talk to the people around you to figure out what those hacks are to improve your score even further. But I would push content knowledge, which is why I won't point out the hacks explicitly.
So it's just basic participation.
large part of it is participation, active participation. With that, we are officially done. If you still have questions, you can still ask them. Just realize we're done.
And that was my
Another question, is lab or required artificial intelligence? I'm trying to get a pathway right from my nurse's degree.
And if it helps, it's good to understand.
Very limited lab seats.
I'm already on the board for like 2 days. I wasn't last week specifically back to Louisiana and then immediately got sick with the plague and so I missed last week. Yeah. So I'm like already kind of like panicking.
So there's a lot of new stuff. I'm trying to figure
Yeah,
out.
I do.
Lots of work going on.
Okay, so
The
there's
majority
no
of the class today
but it's still go into his lab.
starting
So it's basically, lab today is a big huge thing, but the actual like
Yeah.
online lab that we're supposed to do is called the FedEx.
I'm not like so far behind already that I can't catch up.
Now, what's told me,
Most of what was
like
covered
class is when it comes to the isotopes, you have to know the
That's all of what's trying to go.
the isotopes, right?
So
I
you've been watching
also
lecture videos.
feel a little better because I thought like reading like this and the chapters that are known about this are so much material. But
Yeah, even with the chapters, skills. I'm not looking for details.
I'm literally like
You do
writing
better
this,
with
like
detail.
word for word. I have issues. So, okay.
I asked you something similar. About atomic mass.
Okay,
It's
so
not
our first
an
actual
average
lab day
of
is
the
not
total
until
amount
Wednesday
of
next week.
mass. It's an
So
average.
today is of course second Wednesday. We
The
don't have
specific
lab.
number associated with that
Day is
isotope
lab.
and how
On the beautiful third.
each isotope is in that same.
That is
So
just.
I think what you're getting confused
That
on
is
is
when
some of
you
the
need
language
to know how.
associated with it, which is very important.
It's gonna be.
There is a
little
mass
bit, of
number.
course, but
The
it's
mass
at this
number is
point
very
when you
specific
start
when
doing
it's the
stuff,
number of protons. and
such as
neutrons.
measurements of calibration, for instance, which is
There is
what
also
third week
the
is
mass
about.
of the element.
Okay.
That's not.
He said that,
The mass of the element can get divided out into a couple
he
different
did say
categories.
that,
depending on what you're looking
course,
But
when it
very
comes to,
commonly,
like,
when you talk about the mass of the element, or the atomic mass,
the
we're
strength,
talking about, if I grab a sample of hydrogen
you get 3 attempts to do
and
it
I
when you're
took the
operating.
average mass for every single one, or triple the mass for every single one of those particles and averaged it, it
Strike
would be
it
this
once,
number.
doesn't go. Strike it twice, doesn't go.
And that's because
Third time,
not
it does
every
not like
single
the strike. He is
atom
gonna
of
be
hydrogen
rushing
has
over
the same
to
mass.
Right, okay.
So the mass,
There's not gonna be a
the
fire.
average mass
happening
changes.
by you
So
continuing to
that's
push
now
it.
controlled based off abundance isotopes.
And has he shown
That's
us
where
how
you
you're
do
supposed
isotope
to?
calculation.
I don't have one for that.
Okay.
It's
That's
related
what I was
to,
thinking of.
but it's
What-
not
what
the same at all as this.
My lab with
That-
them is
that-
1 p.m.
yeah.
Wednesday.
Um,
You explained it to me last time and I had no idea what you're talking about, but now I know.
Because of the FedEx
Yeah,
simulation.
mass number for me, I remember looking at our old,
I had emailed him.
I think it actually might be the same practice final.
I have a different
I'm going, oh, this is a stupid question, and then eventually I was like, well,
I wanted.
well, somebody wrote it for a reason. And so
Oh, yeah,
really-
I understand what you're saying, yeah, because,
Yeah.
you know, it's difficult when you
Yeah,
have
they-
different instructors
Yeah,
with
I
different
mean,
tools.
yeah, I mean, I know they're teaching the
Very,
same
very,
thing,
very.
but it would
That makes
be
sense.
very beneficial to
Well,
have
I'm
the
saying-
same instruction.
Thank you.
Yeah, absolutely, and also, it's just that, you know, each professor teaches.
Oh, yeah, recording silence. Good job.
So it's